All right, this is part 2 of the balancing equations tutorial from your first homework assignment, balancing equations. You'll do this in your notebook. I am going to use this worksheet and then write really small and fill in the formulas for everything right underneath. So it'll be kind of small, but hopefully that will help you. And again, we're going to use some of our hints from our notes to get through this. So with number 9, which is the first one in part 2, in this section you have to copy the words into your notebook, and then you need to write the correct formulas for each of these also in your notebook, and then you need to balance them. So kind of a lot of parts in this one. So since I'm using the worksheet, I already have the words written. I'm going to write the formulas and then I'm going to balance. So starting with number 9, a lot of things we'll kind of talk about in this video. So for the first thing, copper, when it just says copper, the element, if it's just an element by itself, that's all you need for the formula. So for something like copper, the formula is just Cu. That is the formula for copper, and for many things on the periodic table, all those elements, that's the formula. The only exception are the diatomic elements. You would need 2 of them. Okay, so copper and then plus nitric acid. Yes, you have to remember how to write and name acids. This is from Unit 4. So nitric acid came from nitrate, NO3 minus, and then you need to add hydrogen to make it an acid. In that case, you would need 1 hydrogen, so it's going to be HNO3. There is a video for naming acids if you forgot how to do that. All right, so those are the reactants, and then we'll have an arrow here. And products, the first product is copper 1 nitrate. So this is really good review for how to write formulas for ionic compounds. So remember copper 1, the Roman numeral 1 tells you that it has a charge of +1. And then nitrate, which we just talked about, nitrate is NO3 minus. So you have a +1, -1. Those charges cancel. So it's going to be Cu NO3. So that's the first product. The second product, here we go, good example of what I just referred to. Here's another element, hydrogen, but there's something special about hydrogen. The formula is not H, and maybe you have it labeled on your periodic table. Hydrogen is a diatomic element, one of the super 7, Brinkelhoff. So its formula, it needs 2. There are 2 atoms of hydrogen in the element hydrogen, since it's diatomic. So that's the first thing you need to do, is make sure you have the correct formulas for everything. That is the first hint in your notes, is to make sure your formulas are correct. If it doesn't balance, a lot of times the problem is that your formulas are not right. So this is a really good hint for you to get started on these types of questions. Okay. Now we need to balance it. And to go through and balance one like this, again, you just want to pick something to start with and then go from there. So I'm going to pick copper. So there's 1 copper on this side of the arrow, and so I need 1 copper on this side, and there is 1 copper. So copper is already balanced. We'll switch to hydrogen. So there's 1 hydrogen on this side, on the reactant side. On this side we have 2 hydrogens, so we're going to need to do some work for that. In order to make those balanced, I need to have 2 hydrogens on this side. So I'm going to add a 2. And you don't have to underline this, but I'll probably do that a lot in class to highlight that. So now that there's a 2 there, the hydrogens balance, but I've now just affected the nitrates. Remember, we're going to treat this NO3 as a chunk. We talked about in the last video, we can treat polyatomic ions as chunks. So there are 2 NO3s on this side of the arrow, 2 nitrates, and so we need to make sure that there are 2 nitrates on this side, and currently there's only 1 nitrate. So in order to make that 2, we're going to put a 2 in front of copper nitrate, copper 1 nitrate, and now that 2 affects the nitrates, so we have 2 of those, but it also affects the coppers. So now we have 2 coppers on this side. So we're going to have to go back, even though we thought coppers were balanced, they're not anymore. So now that there are 2 coppers here, We need to make sure there are 2 coppers here. And now maybe we're done, but again, it's always good to go through quickly again, just to make sure that all of your balancing worked out in the end. So 2 coppers, 2 coppers, 2 hydrogens, 2 hydrogens, 2 nitrates, 2 nitrates. So this one looks good. All right, so that's number 9. We'll move on to number 10. Number 10, again, a lot of practice with formula writing, ionic compounds. So iron 3 sulfate. Remember, the Roman numeral tells you the charge, so it's iron 3 plus. Sulfate has a charge of 2 minus here. So we have a plus 3 minus 2. So you're going to have to make those charges turn into 6, plus 6 minus 6. So in order to do that, if I want iron 3 to have a plus 6 charge, I need 2 of them. And then sulfate, which is SO4, I need 3 of those. So again, there are videos for ionic formula writing. This does not go away. You have to know how to do this. So that's iron 3 sulfate. Calcium hydroxide. Calcium has a charge of positive 2. Hydroxide has a charge of negative 1. So we're going to need 2 hydroxides. Do need the parentheses there, very important. And those are our reactants. Draw an arrow. And then the products, iron 3 hydroxide. So this is a plus 3. This is a minus 1. So this time we need 3 hydroxides. And calcium sulfate is the last one. So calcium, this is plus 2. This is minus 2, so those charges balance. So it's going to be CaSO4. So again, we're going to think about this hint. Again, treat polyatomic ions as chunks. This is really going to help you out here. Notice when the ions are sticking together. So SO4, that's sulfate, it's still over here, SO4 sulfate. Hydroxide, hydroxide. So treat these as a chunk when you're balancing. So now we're going to go through, once we have the correct formulas, and go through and balance one at a time and see where this takes us. Okay, so I'm just going to start with iron, as I usually do, start with the first one, as long as it's only in one thing on the left and one thing on the right. So I have 2 irons here, because of that little 2, and on this side I have 1 iron. That 3 only affects the hydroxides. So I need to fix that by putting a 2 here. Now by putting that 2 here, I have 2 irons and those balance, but I've also just changed the hydroxides. I had 3, but now I need to multiply that by 2. So now I have 6 hydroxides on this side. This side, I have 2 hydroxides. So I need to multiply this by 3 to make it 6. So again, you can't change the formula, and it says that on here. Do not change the chemical formulas, but we can change the coefficient. So I want to have a 3 here so that I do 3 times 2 equals 6 hydroxides, and 2 times 3 equals 6 hydroxides. So now the hydroxides balance. And now by putting that 3 there, I've affected the calcium. Now I have 3 calciums on this side. Check over here, I only have 1 calcium, so that's an easy fix. I need 3 of those. And now I've changed the sulfates, right? We're going to treat this as a chunk. So I have 3 sulfates. How many do I have on this side? Great news, I have 3. Remember, SO4 is sulfate, so I have 3 sulfates. I have 3 sulfates. Looks good so far. We'll do a quick review of what we've done. 2 irons, 2 irons, 3 sulfates, 3 sulfates, 3 calciums, 3 calciums, 6 hydroxides, 6 hydroxides, and that one's done. A little scary looking, but not too bad. One more, the very last one can be quite tricky. So number 20, benzene and oxygen goes to carbon dioxide and water. And this is kind of a special type of problem here, which we're going to use our last couple hints. So when I'm writing out the formulas, again, the first step is to make sure you have the correct formulas before you balance. This is a problem most of the time if something's not balancing. So we've got C6H6 gives you the formula for benzene. Oxygen is a special one. Oxygen is diatomic. So don't forget, it is O2, not just O. Carbon dioxide, this is reviewing your covalent naming. Carbon, there's no prefix there, so it means there's one. Dioxide means there are two oxygens. And water, you know that formula, H2O. Okay, so there are our formulas. Now we need to balance. And these ones can be quite tricky. And there's a little hint that I talked about in class, and I'm just going to do it right now from the start because I recognize this as a certain type of problem to balance. And the last hint here says that if all the elements balance except a diatomic element, we can double the coefficients used. So what I'm going to do is, I'll come back to this hint because it doesn't really make a lot of sense right now, but I'm going to balance, kind of follow our hints of balancing elements that are in the least amount of substances first, because that's going to make our lives much easier. So when I look at this, I see oxygen in a lot of things. It's in 3 different things. So I am not going to start with oxygen. What I'm going to do is start with carbon, and this will be the way that I would recommend you do as well. So carbons, I have 6 here. I have 1 here. So if we put a 6 there, again, don't touch the oxygens yet. Usually I would see how that 6 plays out, but this one's a little bit weird. So I've done the carbons. Now I want to balance the hydrogens. So I have 6 on this side. I have 2 on this side. Well, if I put a 3 here, now I have 3 times 2 is 6, which balances those. Okay, so now the carbons and the hydrogens balance. Let's check our oxygens. We have 2 on this side. We have 6 times 2 is 12, plus the 3 here, so we have 15. 15 on this side, 2 on this side, but we have a major problem because if we have 15 on this side, this 2 in the formula is going to make whatever number we put here, it's going to make it even. And we have an odd number on this side. So that's a problem that will happen sometimes. And this is where the hint comes in. We can't change the formula, so it's always going to be even. This side is currently odd, so what we can do is we can double all of the coefficients that we've just put in, and then we'll go back and balance the oxygens. Okay, so this is a little trick that you can use. So this coefficient was 1. We didn't write it, but it was 1. So I'm going to change that to a 2. That's the new coefficient. This one we're going to wait because we're trying to figure this out. This one was a 6. Let's double that to 12. And this last one was a 3. So we're going to turn that into a 6. Okay, so now everything should still be balanced, but it's just double. So now we have 12 carbons, and we have 12 hydrogens on this side, and we have 12 hydrogens on this side. So everything is still balanced. Now we need to consider our oxygens. So now we have 12 times 2, so we have 24 here. We have 6 here. So now we have 30 oxygens on this side. That's good because that's an even number. Now we just need to make this into 30 oxygens. So 30 divided by 2 is 15. Okay, so bigger numbers with these types of problems, and it does require a little trick. But once you get the hang of that, and once you recognize this type of problem, it will very frequently be this form. Not always, but a lot of times if you're having trouble, that trick will help you out. Okay, so that's that last little hint. And then again, the 5th hint was to make sure that all of the elements are completely balanced and in the lowest whole number ratios possible. So once you do one like this where you get pretty big numbers, just make sure that they couldn't be reduced anymore. So 2, 15, 12, 6. That 15, since it's an odd number, prevents us from reducing these by dividing by 2. So this one actually is fine, even though those numbers are bigger than what we might normally want. This one works. Okay, so good luck with that homework assignment. There's a lot to do with balancing. Always refer to those hints and hopefully they'll help you out.